Okay, so in this part of the casement building process, we're going to cut the shoulders on the rails of the casement. Okay, so if you follow the process this far, we'll have rails with the tenons cut in length, and we'll have a couple of pattern pieces as well that we've cut both ends on the same as the other rails, exactly the same. And we've set out this tenon on the pattern piece, so it's the thickness of the stiles to the first shoulder, and then a 15mm setback to that shorter shoulder in the rebate side. So we'll now set the circular saw up to cut the two tenons. So I'm just going to square this line over and see what we're doing. Use the line as a rough guide to setting the saw up, and then we'll measure from the end of the tenon here to that shoulder cut to get a really accurate 58mm, which is the thickness of the stiles. And then when we turn it over and cut from the other side, we can measure again so that we know we've got exactly a 15mm setback on that tenon. Remember, we want to stop on the saw bench, just take them edges off that meet the bed and the fence, so that any sort of flecks of timber left on from cross-cutting or sawdust isn't going to stop that piece of timber from butting up real nice and sharply to that stop. Just set the height so it just takes the material off, it doesn't cut into the tenon. On the casements, you're probably slightly better off being higher than lower, and then just taking the last bit of the material out with a really sharp chisel afterwards. Once we've made that first cut and happy with the height of the blade, we can just tap the stock back until we get that 58mm depth of cut on this shoulder. So this is on the inside face, 56.7. Just going to tap that stock back slightly and make the cut. Touch more. Okay, so make sure you've cut all the rails, the top and bottom rails, and all the pattern pieces with that first cut before you alter the saw. You don't want to be going back and trying to reset it up to that setting. Once you've done that, we can set up for the other side, so it's much the same process. I'm going to just alter the stop I've got here so that it's not quite as high. I'm just going to use the other end and tick it so that just below the height of that tenon, so that as I cut this piece here, the waste material doesn't drop and it's wedged between the stock and the blade, and it's going to cause it to kick or bind on the blade, and that's going to ruin your joint a little bit. So I'm just going to take that little bit of material out on the bandsaw. that joint so that from the tenon we've got a perfect 15mm setback between the two shoulders. Now if you go a little bit too far with the saw stop and cut it, and that second cut is too deep, don't just keep hold of that joint. You've got to get rid of it, so cut it off and dispose of it there and then. You don't want to be using that as a checking piece later on for setting up the rebate and then make an adjustment that is wrong to the rebates. But if you're following a measurement, it should all be pretty easy, but it's dead easy to doubt yourself and check it and then use the wrong pattern piece that's been cut wrong and make an alteration based on that. So if you do cut it slightly deep, just either mark that it's wrong and cross it all out so that you've got no chance of using that tenon as a test piece, or just cut it off on the miter saw. Once we've got the setup correct, run all the pieces through the saw. And if you've got that tiny lip of timber left from the two saw cuts, we'll just take that out with the chisel now while we've got nice big surfaces to rest the chisel on. Keep the piece of wood nice and low in the vise, and it'll help you keep it nice and stable and not get any slippage where you're going to cut yourself. So you can see why it's important to get really accurate cuts with the saw. It makes the stages like this nice and easy, so I've only got to take a really tiny sliver of wood away here to clear that joint. You can of course cut deep enough to clear it from both directions. You're best off cutting in the shoulder direction to clear, so that you won't see that cut, but you are weakening that joint, and as in the casement is the weakest part of the joints on a window, you want all the strength you can get within that tenon. Just put a mortise in one of the pattern pieces, wider than the top rail of the casement, and I'm just going to use that now that we've cut the shoulders as a test piece for the fit of the joint. So flush fit's pretty good. Using a method involving a circular saw or a band saw, I'd say anything within 1/2 mm of flush is pretty good. And like I say, you want that the fit on the joint to be nice and snug. You don't want it too tight that you're having to really hammer it home, but you want it just tight, because like I say, the casement joint in itself doesn't have a huge amount of surface area through that tenon, so you want to make the most of what you've got. Now that the mortise and tenons are fully complete, we can move on to the spindle moulder and put that rebate moulding into the casements. Right, so it's time to fire up the spindle and rebate the casement stiles. We're using a 50mm rebate block. If you've got a spindle moulder, you've probably got a 50mm rebate block. They're pretty common. It's sort of a standard block. It has been an industry standard block for ages. More recently we've seen a sort of influx of taller blocks, and there's a lot more available now with spindle tooling than there ever was. So yeah, there's a lot of different tooling out there, loads on sort of second-hand market that can be bought quite cheaply, but if you've not got a rebater block with the carbide knife inserts, then I suggest you get one, because it's the most used tool on the spindle moulder. If you've got the capacity on your machine, I'd look for something like that. It's probably a bit more outlay for a start, but you've got 100mm cutter height there, and you're never going to sort of run out of cutter height no matter what you're doing. So, but going back to the frame moulding where we rebated them and had to do it in 2 different passes with the 50mm block, a 100mm block would be a nice simple task of just doing it in 1 pass. So to set up on the spindle, all I do is get everything to a basic setting that's near enough. So we're looking for a 43mm rebate, so we've got 15mm left on to hold that glass in. So I'm going to raise the cutter up to nearly that height. On this machine I can set the height electronically, but will work as though it's a manual machine. So the height of the rebate is roughly where this tenon position is. So we're just going to wind the machine up until we're just slightly below that point there, and leave that setting at that. Now I'm going to machine the rebate in a couple of passes, so I take about 3 to 4mm off in the first pass at full height, and it'll give us a really nice clean edge along that piece of timber. If you cut too much in one go for a start, you can, even with the spur cutters on the block that help to reduce the amount of breakout on the cutter, you'll find that the edge that's left from that rebate isn't very sharp. You get a fair bit of timber and grain breaking away. So just do a nice little 3mm cut for a start. So I'm just going to set that to by eye to about 3mm. Then we're going to set the fences. So the back fence, the left-hand fence, can be set about 5mm away from the cutter. Then I just give a bit more room on the front fence here. So I've got about 3/8 to 5/8 gap there, so 15mm from the cutter. Tighten everything down, we'll turn on the extraction, make a first cut, we'll check it with the measurements, then adjust accordingly, and then we'll put the power feeder in place and push everything through. Okay, so we're after 43mm by about 3mm depth, so the setting we're going to just set up at the minute is that 43, so I'm nearly there. We'll just raise that cutter up. If your tenon is slightly off in position from where we wanted it to be, I would personally raise the cutter until it removes this lip of timber. If it's not perfectly on that 43mm mark, if it's lower, so it's already cleared that piece of timber and you're not quite up, that's fine. You've got to make that rebate deep enough for what we need, so go to 43mm. Okay, so we'll run all them pieces through using the power feeder at that sort of shallow depth at the height we want. I'm going to set the power feeder to a nice slow speed, so it leaves this corner here of the rebate really nice and sharp. The orientation we're going to push them through at is the face and the edge, face up, edge to the fence, so in that orientation there. The reason for that is the glazing rebate is on the outside and the face is the inside. You want to really pay attention to what you're doing when you're pushing these through, because pushing it through in that manner so it's the wrong way up, so the face is down, it's really going to knacker it up and you've got to start again. So I've moved the power feeder away from the fence just for the purpose of filming this bit. So as you're machining the rails, it's going to cut away at the tenon as you're machining it, so you've got to just hold on to that rail for a little bit longer than you would normally when the wood's entering the machine until until this section of the rail meets that back fence. If you don't hold on to it for that little bit longer, the rails will tend to dip into the machine, and then this section will actually catch into the end of that fence. It will create a nasty little divot in the cut of the rebater. So hopefully you can see from that position the effect of the cutter machining that tenon away. So as you can see, it's not until this piece here that there is support on that back fence. And we want to push the stiles through at the same time as the rails at that same setting. Now we're just going to move that rebater back, so I'll move the fences back and deepen that rebate until we got a measurement of 15mm on that cut. So we're looking for that exact 15mm or whatever it's worked out to be on your two rail shoulders, so the difference between the two. It's up to you whether you do this in a couple of passes or go straight for 15mm. Once I've done that 3 or 4mm initial cut, I get the setting for the 15mm and then cut it all in one go. If you've not got a powerful enough spindle or sharp enough cutters, don't be afraid to do that in a couple of passes to get that cut done, especially if you're using something like a router table. You can use that test piece with the mortise in it to set this cut up. So when you're at your 15mm, you can use that full width mortise to check against the top rails. I've actually ended up cutting the rebate in 3 cuts because this is only a 2-cutter rebate block, and I'm used to my other block, which is a 4-cutter. So I've gone to about 13mm, 13.5mm, and then done a further cut, or a last cut at 1.5mm to get my finished thickness. Sorry, finished depth of cut on the rebate. Now you want to be absolutely perfect across these fence surfaces here when you're rebating to get that accurate rebate along the full length of the stiles and rails. So I'm just going to have a real good clean down of the beds, and like I mentioned in the other videos, just make sure all the dust is off this surface that the fences sit against, and the back of the fences are clean, and that will ensure that you get a nice parallel fence set up between the two. Especially this in-feed fence, because the material is thrown this way, you tend to get just a bit of dust build up on that surface there, and that will tend to throw that fence out very slightly, which means you have to adjust the back fence out to meet the timber. And as it's fed through at an angle, there'll be a certain point at which it switches from pressure against that in-feed fence at an angle to this fence, which is parallel, and the timber will move like that, and you'll get an alteration in the depth of cut between the in-feed side and the out-feed side of that piece of timber. Okay, so wind that rebater back until you get the read of measurement that you want on your vernier caliper. I've got just over 15mm, so 15.1 on average across this piece. My tenons are actually set slightly long at 15.1, so that's worked out perfectly. So what we're looking for is a perfect measurement on the rebater against that edge there, and we're also looking to check the joint physically with either a pattern piece or one of the rails and put it together, and that is absolutely silky sweet. Look at that, perfect. So there shouldn't be any gaps on either shoulder, and nice and flush across the joint. You might see a bit of variation on the outside edge in the joint, depending on how good your thicknesser is and how accurate each piece of material is on thickness, but it's the face that's important, and that should be fairly flush. Like I say, about 1/2 mil tolerance on a saw cut tenon is probably pretty good going. So that's what we're looking for. And as you push the joint together, you just want to check it with a ruler across the top, so that or cast a ruler along the fake style there, the pattern piece, and make sure it's in line with the rail, so that if your tenon is slightly out of sync with parallel on here, you want them shoulders to try and pull it back nice and square, so the shoulders actually do some work there in keeping that the casement nice and flat. If you've used the measurement method, vernier calipers, it's quite accurate. You should end up with a perfectly flush joint out the other side of that piece of timber. And if you have, that'll be a lot better than a lot of joiners' work that I've seen. So there you go, well done. In terms of fit of the tenon, that sort of fit thickness that we're thinking about when we're setting that saw cut up on the tenon, this is the perfect joint really that I've got here. It wants to go together in its finished form with just enough pressure that it's able to go together by hand. So and it will hold itself together once it is together, but it doesn't want to be so hard that you're having to really bash the casement together with a mallet. So that's the perfect fit right there. That measurement to get a perfect fit like that is going to vary depending on what you're doing. So a casement joint like this that's quite small, it's going to be a slightly tighter fit in terms of measurement on the tenon versus a door style and rail, which is about 120mm long tenon. You're going to have to just take a whisper more off the tenon to get that nice pushed together fit. It's really important as you're pushing each bit through, especially the stiles, that you watch this gap along the top of the fence here, that there isn't a gap there, that it stays nice and tight as it passes through the cutter. If you see that gap open up like this at all near the cutter when it's travelling through, it's not going to have cut to the correct depth on that piece, and you need to just run it through again and make sure it does cut nice and tight. So that's going to affect the joint fit on the stiles. Right, so now the rebating's done on the stiles and rails, we want to be really careful we don't damage this inside edge here. That's where the glazing tape will sit up against, and any damage is going to show up like a sore thumb, especially on a stain job. If you're using a black tape, it's just going to highlight any missing bits of grain along this edge here. So that could be the machining finished if you don't want to do this next step. But I like to add a 8mm diameter drip groove through the rail of the bottom rail, and it acts like a bit of a drainage groove. If you did get moisture in there, you'll see it trickling out the end of the tenon, and it also gives you sort of an opportunity for it to vent a tiny bit through that casement where the unit is sitting. So it will still be a sealed system, so you'll still be sealing the bead in to the outside of the casement, but you've just got a groove running through to the sides of the casement with that hole in it, and you can even clean it through after a few years with a long sort of rifle brush and actually clean that hole out. So for me it's a good way of knowing if the beading or the sealant on the glass has actually failed, because you will see a trickle of water coming out of the joint. So all we do to set that up is have a 8mm cutter in the spindle. We just set it in the middle of the tenon, height wise, and then I'm going to set it about 8mm in depth, so it will cut into the wood 8mm. Actually, maybe not quite 8mm, go to 6mm, and then the final 2mm can be drilled out of the wedge once the joint has been wedged. That's all the spindle moulder work done for the casements before we glue them up. So the next stage we're going to cut the haunches. We just need to clean this material that's left by the mortise chisel. So we're going to use a nice sharp chisel. I've got a paring chisel, and just cut down into them haunch rim parts of the mortise and clean that material out. Now, because we've mortised past that line in the end of the casement, we don't need to get a small chisel and remove that bit of waste that's on the end grain. We can just work up to it, and that'll clear enough for us to get the rails into place. If you want a really neat joint and a nice tight haunch, you can take the mortise, set the mortise so it doesn't cut quite so deep, and chop them parts in by hand or with a router to get a nice square bottom to that mortise haunch section. But it's the top edge of a casement, it doesn't really matter that that haunch is going to have them marks in it. Same on the other end. Okay, so now it might make sense to you what the haunch depth setting was on the mortiser. So if you think back to when we were setting the two depths when we were mortising, we set one at halfway so that the chisel cut through beyond halfway from both sides of the timber to create that through mortise, so it's nice and clean where it meets in the middle of the timber. So that surface there where that chisel has cut from both sides is nice and clean because it's gone past that point each time. Then the other setting was this haunch setting. So the depth of the material from this rebate here to the haunch was that second setting. So that is effectively leaving us with a different wedge length no matter what that setting is. So we're about this deep on the haunch here, and that material that's left there is our wedge length, so what we'll need to make our wedges to hammer into the joint. Hopefully that makes sense as to what it is. The purpose of a haunch in a joint like this is to stop it twisting. So if you just cut that tenon through at that point at 30mm on this bottom rail, and then cut the rest of the joint off flush with this shoulder here, so it was just a flush shoulder and a tenon, and you wedged that, it'd be quite strong, but there'd be nothing throughout the whole width of the rail stopping that rail from twisting. So we've actually got that mortise in there, in that small housing, stopping that rail from being able to twist, which is going to strengthen the joint, and also you've got all that glue surface area as an extra sort of strength and bond within the joint itself as well. So some joiners, everyone's different in sort of the sizes they use slightly, but some will favour a bigger haunch and a smaller wedge because you do actually get that greater surface area of glue. So it's sort of up to you to sort of feel and find what works best for your purposes. I sort of try to find a happy medium. So in a casement like this, you've got about 35mm of wedge, something like that, and about a 10mm haunch depth. So you've got a fair bit of haunch there for the glue to actually set to and stop it twisting, but you've still got a decent sized wedge to actually work the joint. Right, so all that talk about haunches, we can move on to the rails and cut them. So we need to get a measurement for the depth of the haunch. Several ways of doing this. The easiest way is to measure from one of these shoulders. I generally go from the taller side because it's easier to work with. If you've got quite a narrow haunch, say it was a 5mm deep haunch, if you worked from this shoulder here, you've got to try and mark the 5mm setting on the actual shoulder of the tenon, which is quite difficult. So if we go from the taller side and measure down to that the bottom of that haunch cut, so We want to be nice and accurate with this and check quite a few of them and go from all the way across that joint to make sure it's nicely flat bottomed, that mortising there. You want a nice flat surface to reference from. So we'll take that measurement on these. What we got? Let's get me head in line with it. At 25.5 mil. 25.5. 25. So it's about 25 mil. So we'll do a 25 mil haunch from that surface on the rails themselves. So I've got a pattern piece here just to set this up so I can show you. Camera's in the way of it here, but I'll try and work with it. So we're referencing from this inside face the taller edge here, so the longer shouldered joint, and we want to mark 25 mil from that surface. Okay, so we want to mark that 25 millimeters nice and accurately, and we can square that across. So that's the depth of our haunch. Then we need to set the width of our tenon in the other direction that we're going to wedge against. So we set that out earlier in the marking out of the styles, and we, on the smaller rails, so the top rails, it was 16 mil. So we want a 16 mil mark, can't see it again, on there, and we'll square that line up as well. So effectively that's the material we're going to be cutting away, and that will make up our wedge section of the joint. So you've got options now of how to cut this. I've just got 2 casements to do, so I'll cut them by hand. Tenon saw down here and along here, but you could set up a bandsaw to cut all of these in one go, or set up a stop or a fence to cut that line down, so you only need to mark it out once, cut to that point and set up an end stop so that it will meet that end stop and not go too far into the rail. And you can do the same for this cross cut as well, so you just set it up once and cut away until they're all done. The haunch setting for the bottom rail is exactly the same, so we've got that same 25 mil. So if you're setting something up to cut that out, it can be set the same and run through at the same time as them top rails. Obviously we've got a slightly wider joint in that bottom rail at I think we did it 30 mil. You can in fact tick these off of the traditional way. It's just to tick the end, so line it with where the mortise is and tick the mark that we've worked from. You want to just come in ever so slightly, so if it's a 30 mil tight 30 mil mortise, you want that to be about 29.5 mil, so you've got just a tiny bit of wiggle room to get the joint together and apart. There we go. On the bottom rail, the waist section looks like that, and that will be our joint. I decided to cut them on the bandsaw just to show you how I do it on here, because it can lead to you pinching the blade and stuff if you set up wrong. So I just set the fence to the haunch depth first and then cut all of them, so you can cut both the top rails and the bottom rails. You want to set up a stop behind the blade so that you don't cut too deep into that tenon. As with the crosscut saw, you want a stop that's not sitting on the bed itself, so that the sawdust doesn't affect the depth setting. Remember, you're cutting in from that top and bottom edge and not the rebate side, so don't go and cut your tenon off. You make sure you always go in from the back there. Remember to run all of them through, and then we'll adjust the fence so that it suits that long cut here. We want the inside edge against the fence so that when that piece falls off, it falls to the outside of the blade and doesn't pinch between the blade and the thing. It's dead easy to set it up this way around, but when that piece is cut and dislodges, it pinches in the blade and can affect the settings and snap the blade as well. Those two cuts want to just intersect nicely in the corner. If anything, if you're going to clear it one way rather than the other, you're best off doing this cut now slightly deeper and the other one slightly shallower, so you're not weakening that grain through the joint. We just want to check that that measurement fits with our mortise chisel size. So it just wants to be a hair under the exact size of that chisel. So we were 15.86 measurement on the chisel surfaces. So yeah, as long as we're at that or under it, that's absolutely perfect. And it's the same process for the bottom rail, and we can leave that stop on the fence and it will be in exactly the right position. It should be. Touch more FM. Keep hold of these bits that are the offcuts of that joint. We can actually use these to make the wedges. Now we can bring our stiles into the bench and we can just check the fit on every rail and stile joint. So we can, if these are already labelled up with where they go in, so if you numbered them or lettered them appropriate to a specific window or casement, you want to get them joints and make them together. If you're checking the fit between the stile and a rail, you can then mark that joint and you know that joint 1 will go together, and you know it's a good fit when you come to gluing up. So this is the first time we're going to put the rail into the actual stile. We'll just push the rail home into the mortise. This is quite a big rail for a bottom rail on a casement. And the joint's probably just a tiny bit tight there, so I can get it most of the way home until it reaches halfway into that haunch, and it's just tightening up. So it will actually go together quite nicely, and it can be manipulated in there. So that's a bit tight of a fit, a bit tighter than I'd like it to be. But it does go in, and that would be fine to glue up. If it doesn't go home and you have to bash the hell out of it to try and get it to go in there, you just want to take a little bit off the joint. You should be able to, after you've done one, see which way, if you've got a discrepancy in the flush fit of your joint, which side will need relieving to help any tightness issues. So there's a tiny step there against the stile, so I'll take some material off this this side of the rail to bring that out and meet it, and that should just loosen that joint up a little bit. So you want to use a bench hook to do this, or clamp it into the vise, but for the purposes here of the camera being in place, just going to use the rebate. So we're just taking a sliver with a really sharp chisel off of that joint to relieve some of the tension within it. Again, you're taking it off the side of the rail that you want the step to be taken out from if you've got one. And it's just a very, very light shaving. So as thin as you can get a shaving off of that joint. And only take a tiny bit off the end because it's nice to keep the ends of the joint really nice and tight. So it doesn't matter too much if 5mm of the end of that tenon is really tight in the mortise, because then on the outside of the casement it will look like a nice tight mortise line. You can actually relieve some tension from beyond that point, so sort of 8mm back you can hollow it out very slightly to loosen that part of the joint up, and it should slip together quite nicely. And then when it gets to, if you leave the last 5mm of the haunch, again the same, if it's tight, and just relieve a bit of tension up to that point, it will make the joint a nice tight fit when it just comes together for that last 5mm. So that's perfect, that is. Just a bit of tension to get it to sit home, and it's not exerting any sideways pressure in the joint, and it's flushed it up quite nicely actually. So once we've done that, we can put a pencil mark on the face of that joint. You know, it could be casement A, and we'll just label the joint like that. Same principle for all the joints. Remember to keep them in pairs, and keep your rails in pairs now as well once you've started fitting them. So if you've got your machining about right, this process should be pretty quick. But don't be afraid to take some time getting these joints right. It's definitely going to save you a bit later on when you come to sanding these joints nice and flush. So that top rail is about perfect. There's a nice bit of tension there to hold it in place, but it's free to move and quite easy to assemble and disassemble. So we'll just put a pencil line on there again so you can see. So that's style A, and we'll put another A on there, and that could be casement 1. So if we grab the opposing rail to this one, that style, so by opposing style, this is the one we've just fitted, number 1. We want the other hand piece like this, so that the rebate is the opposite when them two top rail joints are in line. We'll do the same process with this style, using them rails we've just fitted into the other piece. So this will be labelled up casement 1 again, but the joints will be B. It's going to be a bit tight again, so I'm just going to relieve it, same as we did on the other side. So this chisel wants to be absolutely razor sharp to get a nice fine shaving off here. If it's anything other than that, you'll find it will follow the grain and create a right mess. Just a tiny bit off the end of there. We'll try that. Little stages at a time, little cuts, until that cut goes nice. So that's still a bit tight. So look down the flushness. If it is really tight like that, you should be able to see against the light where it's rubbing on the timber. The two surfaces are tight, and you can just take them surfaces off, because they're the high points of the joint. Okay, so it's home, but still a little bit tight. I'll just keep taking a tiny bit off until that's a nice fit. Again, it's nice if you can get this in a vise while you're fitting it, and then you can use 2 hands on the chisel and be a lot safer. go, we can label that one number 1B. And then all 4 pieces should be able to go together. Right, so both casements are now fitted together as a dry fit on all the joints. I'm just going to stick a sash clamp across the casements and clamp them up so that we know absolutely sure that them joints are all going to fit together and work. The point that you'll fall down on now for the joint not going together is if your haunches aren't quite right and they're bottoming out before the shoulders of the joint are up tight. So the haunch we chopped in to the mortise position will bottom out if it's too long. Right, so while it's clamped together and the rails are seated up against this inside line that we've got for the mortise, we can just take a measurement of what we've got for our wedges. So we're around about 5mm, 6mm there. It's gone a bit big on that back side. So you can see I've actually gone the wrong side of the line, or just chopped a little bit too much on this wedge. That's the one that we wanted to be slightly shorter, so that at this point here, the wedge room would be equally the side of the tenon. It's not the end of the world, but it just looks nice if they are even. So we want a wedge to go in these housings. It wants to be about 1mm bigger than the tight size that's there currently. So if we say that's 5.5mm, if we make sure the thick end of the wedge is at least 6.5mm, we should get a nice tight joint when it's wedged up. Okay, so remember these little pieces of timber we had left from the haunches that we cut on the tenons? We're going to use these to make the wedges because they are the correct length for the that piece of timber that's left between the haunch and the outside of the casement. So we wanted about 6.5 to 7mm on the thick end, and it wants to be about 1mm thick on the narrow end. So I've marked that out on the wedge itself there, and you can set that up on a parallel piece of plywood to create a wedge jig. So it's not really going to work with the wedges I've got there, it's a bit too sharp. So I'm just going to cut a new wedge jig. Won't work on that one. No. So we'll transfer that pyramid shape onto a parallel piece of narrow plywood. I've actually got enough room to fit it in just here on this piece. So I'm just going to sit the piece of plywood over like this and tick round the bottom side of the bit of wood and then cut that out. Take the little wedges back over to the joint and just try them in it. They don't want to go in too far that they're not going to be able to actually physically wedge anything, but they don't want to stick out too much. They're probably just a tiny bit too big as a wedge. They're not going to actually hammer in fully home and give full strength to the full depth of the wedge. So just going to take a tiny sliver more off of them and then cut them all out off of them little blocks. There we go, that's the wedges. So try to use the offcuts, and it's a lot easier to use the wider offcuts from the bottom rail than it is the top ones, and you should get at least 4 out of each cut, which will give you enough for that casement. 4 out of each cut, which will give you enough for that style, so you don't really need to use the offcut from the top rail to create your wedges. So So there's not an awful lot to do before we glue the casements up. I'll just disassemble it. Okay, so in my joints I'm going to do the same as on the frame and run a 3mm round over piece along that shoulder and around the inside of the casement there, and the same up the stiles through the joint. If you're not going to be doing that and you want to leave that flush finish joint, so it's that is our finish joint there when it's up nice and tight. You've got to be really careful when you sand these inside edges along here and here that you don't sort of tip the sanding and open up this joint as you do so. So the next job is indeed to sand those edges. Like I said, if you're not putting that round V-groove in there, you've got to be really careful. I think the best way is to use a hand sanding pad, and you can even use a bit of a guide on your sandpaper to keep it nice and flat, and just gentle pressure and just enough sanding on this joint to take the pencil line away here and sand the planar ripples, and you don't want to take too much material off from this actual joint. This sandpaper is about dead, but you get the picture. That will leave you with a perfectly sharp corner on that front still and a sanded surface. If you try and sand it by hand on 50mm, you might just manage it if you're really careful, but it's dead easy to just wobble that paper and take that edge off, and that's a nasty little gap that needs filling or something doing with it, and it's always going to show up. So that's about the only way that I can recommend that keeps that sandpaper really nice and flat and creates a nice sharp joint. Again, this is really where you can thank yourself for taking a bit extra time and doing that last little pass on the thicknesser at the stage where we got the material out, and we've got a nice finish on this edge and we're not going to do too much sanding. It's exactly the same process for the rails as well. Okay, and I'm just going to put the 3mm radius on all them surfaces, the same as the frame. So don't need to do the outsides or the very extremes of the casement, but we do need to do the end grain of the joint and the inside of them rails. And again, the end grain on the outside and the inside edge of that rebate surface where we can't get to when it's been glued together. On the stiles, it's just the long run up that rebate surface, and again on the inside face against that inside edge. Right, so the casement's now ready to glue together. I'm not physically going to glue this one together, it's going to be supplied flat pack, so Mark can reference the joints and the sizes and sort of inspect them and reference to them when he's machining his own components to match. So he's going to make the rest of his windows to match this one. But if you have a look through my sash window series, you should be able to see me gluing up a casement and how I go about it. A few points to consider: when you're applying the glue, get plenty in the mortise so you can really coat the mortise well with the glue. I use a PU glue. I think it's about the best glue for this type of application, especially on oak, because you're going to get a bit of movement in the joints through seasonal changes, and the polyurethane glue has got quite a decent flexibility to it, so it's going to move with the sash rather than just crack and break the bond. So get plenty of glue in the mortise. Get plenty on the outside surface of that shoulder on the rail, so the end grain, because it's going to soak it up well through the end grain, but specifically the outside, so that is sealed, and you want just enough on the inside so that it soaks it up and then leaves a coating on that inside surface. If you put too much on, it's a bit of a nightmare to try and clean it off. It takes forever. Just coat the tenon up so that it's got a layer of glue on it, but not too much excess, because if you put that into the mortise, it's going to peel up along the mortise and then just come out as glue squeeze all around the shoulders and be, again, quite a nightmare to clean up. So just the right amount on the tenon, and get plenty in the actual mortise itself. You want to put your clamps on either side so that they don't interfere with the mortise position. So once we've got the 4 joints glued and together, we'll drop it onto a pair of clamps waiting on the table, and we'll clamp them across the casement nice and parallel. You want your clamps parallel to these rails, just to fully make sure that it's going to end up square. If these rails are nicely seated up against the inside lines, so you tap them down the casement to them inside lines and then clamp it, do that both ends, it ensures it's going to be parallel, so it's, you get a square casement at the end of it, and then you run the clamps in line with them, you know that they're clamping square too. You want one underneath, perhaps on the outside, and you want another clamp the other side of the rail on top, so you're clamping from both edges, so you get a really nice square clamping action across the casement. And we end up with a joint clamped either side of the of that rail, and we just want to make sure that the tenon is tight up to this line here, and you don't see any gap on the inside edge. The easiest way to see is against this line here, because by this point with PU glue you'll have a load of glue squeeze on this inside corner and won't be able to see if there's a gap or not. Then we put our wedges in, so there should be plenty of glue in that mortise that you shouldn't need to glue the wedge itself with PU glue. I won't tap these fully home, but when you're wedging, you always wedge the outside wedge first, but you don't want to put too much pressure on it, so don't drive this one fully home before you've got this one in. In fact, I always put this one in first, which is against everything everyone will tell you, but if you put that wedge in just so it takes the slack up to that line, you don't want to go any further than that, and then you know that tenon has got a nice flat surface all the way along that joint to seat up against, and then you can hit this wedge in and it will keep this piece of timber tight against that flat surface, so it's not moving anywhere. It's exactly where it's supposed to be in regards to the setting out. If you don't tap that first wedge in, or the front wedge in to that initial point, to that line, what can happen is you tap this one in a little bit too far and it will actually physically bend the piece of wood that forms the tenon, and that can lead to it either breaking or just being a bit weaker, or even splitting the rail down here. So it's not necessary. You can just tap this one in until it meets that line and you start feeling a bit of resistance, then tap that one in a bit more and then go back to this one and start driving it home. But we're looking to the perfect finishes for them wedges to make it pretty much exactly flush with this casement by the time they're hammered home. You don't want to apply too much pressure with the hammer. It's just a nice gentle sort of tapping action. You don't want to sort of mar the ends of these wedges over and destroy them, and try not to miss too. It's dead easy to miss the wedge and put a big dent in the side of the casement, and that's exactly what we don't want. Once them wedges are driven home, we can remove the clamps, leave it sitting where it is, and we just want to check the corner to corner measurements are the same. So we would just use a squaring stick and put a tick in where the corner mark is, and then check the other reference corner to corner on the diagonal, and they want to be exactly the same, and that ensures that our casement is nice and square. Okay, so I've actually took one of them pattern pieces that I had, and I've just mortised a a top rail joint into it basically. So this would be the stile and this is the top rail. I've just dry wedged that together in the vise here in the workshop. I've not clamped it and not glued it, just put the rail in the vise, sat this on top and then hammered the wedges home into the back of the joint. I'm going to cut this open on the bandsaw, so cut it in half, so it should give a good explanation of what the joint looks like inside and a few of the reasons, sort of a visual backup of some of the techniques we've used during the manufacture. Okay, so there we have it. That's what the joint looks like inside. So this is the top rail and this is the stile. You can see how them wedges act on the tenon to hold it in place. So as they taper down into the sort of the shoulder of the tenon, the wedge really is compressing them wood fibres just here. So we need a little bit of meat left on that wedge at the tip, because that's really where the strength in the joint in that wedge is coming from. So we're getting a lot of tension here and not too much here. We just want just enough there and more in that centre of the joint. And what that will tend to do with the grain on this top rail is to slightly elongate it or compress it in a fashion like that. So if that's done from both sides, it's creating like a locked joint within the piece of wood. So that point in the tenon is actually narrower than that point there, so this cannot be pulled through that bit of wood and come loose. It also provides a good visual representation of why we mortise from the back first. So if we go back to when we were on the mortiser, putting this joint in here through the stiles, we start from this back edge where the wedges are first and did the through mortise, then cut the wedge room into these two pieces here, and then we turn the piece of wood over and we cut through that mortise again, and then we put the haunch room in afterwards to this line here. The reason we did it that way around, as you can see now, if you'd have started from the inside edge, so you'd have done through mortise here and took the haunch room out, then turned it over, you'd have this cavity here already in place, and then when you go through with the through mortise, you're quite likely to break these bits of wood here, and then even more so when you come to do the wedge, those pieces of wood are just going to, they've got nothing supporting them, backing it for that chisel to cut against. It's just going to break that material away. Next time I make a flush casement window, I'll continue the series through the gluing up stage and finishing, like hanging the casements and glazing as well. But for now, this series is going to stop at the dry assembly of the casement. All that we've got left to do is get the subsill out and the beading for this casement.